What is cloud security? What are the different cloud security models? How do you achieve cloud security through policies and procedures? How do you achieve cloud security through identity and access management, which is IAM? How do you achieve cloud security through networking management? And finally, through storage management. These are some of the questions that we are going to be answering in today's video, which is Intro to Cloud Security. And this is a part of the network and system security module inside of the security engineer pathway of TryHackMe. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. And if you want to get more videos like this, then go ahead and like, subscribe, and turn on that notification bell so that you can get notified the next time that a video drops on this channel. Now, without further ado, let's jump into the introduction of the cloud security room. All right, by now you should have probably heard of cloud computing in some capacity at some point. It's become really popular, especially as it becomes cheaper for the infrastructure and all of the server rooms and the physical infrastructure to be set up so that companies like Google Cloud and AWS and Linode and all these different companies can provide cloud computing services to us. And it's an evolving world, and so the term cloud computing is an evolving term. And to make it as simple as possible, cloud computing means delivering computing services over the internet, which is considered the cloud. So the customer, being you or me or a company, they don't need to buy and maintain physical data centers and servers like the traditional world. They rent those things from a company like AWS or Google Cloud, right? Or Microsoft Azure, stuff like that. So all of the services that they would need would come from a pay-as-you-go pricing, meaning pay per usage of the service, and you can cancel it at any point, buy it for or rent it for a couple of weeks and cancel it. So there's a lot of different ways that you can do it, and it offers scalability, it offers flexibility, allowing you to do a lot of cool stuff. And we discussed this in one of the previous videos when we were talking about virtualization and containers and stuff like that. So we did go over that already. So what we're going to be talking about in this particular video is the security of those environments. So very much like having a physical computer, there is a lot of vulnerabilities that comes with having a cloud-based computer or virtual machine. And so as a security engineer, it's our job to make sure that those computers and the services attached to those computers are all secure. Some of the prerequisites that you'll need is HTTP protocols and servers, as well as principles of security. I've already done a video on security principles, so you can go check that out. And HTTP protocols and servers, we've already actually done as well, but you can just go and check these things out. But there is already a video on this as well. So protocols and servers for HTTP and just the regular stuff. So you should be familiar with all of these things already. If you're not, go ahead and check out those videos so that you can get familiar with them before we dive into the rest of this video. So now that we've gone through that, let's talk about architectural concepts of the cloud. As we talked about in several other videos as well, and again, you've probably heard of this by now as well, characteristics of a cloud come in 4 general categories, I guess, that we can talk about them. And all of these things are meant to serve business continuity operations, which is acronymed as BCO. And there's a lot of different services for, or reasons for this, benefits for this. Purposes. There we go. That's a good word. So storing data, taking backups, disaster recovery, all of those things fall under continuity. So being able to continue operations for a business, all of those things are really important to do that. And then you have the option of scaling. So if you wanted to scale the virtual machines that you have because you hire 10 new employees, or you need just more power for one particular server, you can do all of that. You can buy resources at a time. then buy upon the need of your business, and then they can be scaled up or down for the needs of your business. And then you have simplicity, just making it super freaking easy to do all those things. Nobody needs to learn how to set up a server or build a computer, anything like that. With a couple of clicks, usually you can just get something running. And same thing with a couple of clicks, you can get rid of it and delete that computer and just never have to worry about it again. Cost effective, super, super cheap in a lot of cases. For literally just a couple of bucks per month, you can get a virtual machine. And like the more expensive ones would be like, let's say $50 a month or something like that. And then versus, comparing that to several $1,000s for one computer. It's not even comparable in a lot of cases. And then you can customize the stuff that you're getting so that you only pay for what you need. And then as soon as you're done with it, you can just get rid of it. And again, it'll be like, if you only needed it for a month, you just use it for a month and then you get rid of it. So for $40, $50, you got something done, versus having to spend a few thousand just to build it and then worry about selling it and all of that stuff. So, and then you have enhanced automation. So there's a lot of great automation stuff that comes with most cloud computing services, that they limit human administration. So if you need to scale something up, you can just click a button and it'll scale it up when it reaches its capacity. Or if you need to set up some kind of a backup just in case one crashes, and you want to continue the operations of the business, you can literally just click a button. And for whatever reason, if the main server that crashed, or the main server that your virtual machine was on crashes for whatever reason, it automatically goes to a backup server, so your business just continues. And that's like a really, really important benefit, because sometimes an earthquake could happen, or like a fire or a hurricane or something could happen, and the physical server database or the physical server warehouse can crash or go out of service, and then you will be SOL if you didn't have that backup. So all of that stuff is just some basic but really important benefits of having cloud computing. Then we have the models of cloud computing, and they go into different tiers and levels as well. So you have infrastructure as a service, platform as a service, and then software as a service. So infrastructure as a service has a few distinct characters, and as you go further along in this, it becomes less and less required for management from us as the users, and setup and configuration and stuff like that. So infrastructure as a service, the customer has complete control of the operating system, servers, and applications. The cloud provider maintains and provides data centers with racks, machines, cables, and all of the physical utilities. So they have all the infrastructure. Our responsibility in this case is to manage the logical resources like the software and the operating system. So they let you have the machines and the physical infrastructure, but then you would have to install an operating system on top of that, and then install software on top of that. Then when you go a level up from that, the servers, the responsibilities of the cloud provider ends up being the infrastructure and the platform, and then customers can choose the platform that we would need, and the service provider is just responsible for managing the infrastructure and the platform. And the only thing that the customer would have to worry about is installing software based on our requirements. So in this particular case, you get a Windows machine, for example, and then all you got to do is worry about installing the software on the Windows machine as you need it. And then finally, they have all of these things provided for you, and then the only thing that you need to do is just choose the software that you want to use, right? So in software as a service, everything is managed by the cloud provider, including infrastructure, OS, and the software, and all you're literally doing is choosing which one that you want, which type of software that you want to use, versus the other one. So if we were to use kind of like an example of this, you could say in this one, you're choosing to use Microsoft Exchange, for example, or Outlook, which is the software. In this example, you're using Outlook, but you also need to worry about installing the Microsoft machine. And again, it's not like you have to actually do the installation. You just choose to do the installation, and then they do the installation in the background for you. In this particular case, you end up doing essentially making all of the choices. So you say, I want a computer that has all of these capabilities, and you pick and choose what types of RAM and processor you want to use. On top of that, you would choose what kind of OS you want to use, and then once you have all of that set up, you choose what type of software you want to use. So it becomes more controlled in this environment, but it also means that you need to be better at managing the resources, and this is less controlled. You just choose the software that you want to use. To show you the comparison between on-site infrastructure, platform, and software as a service, you get to see what you would have to manage and what the service provider manages. So the blue boxes are the things that you have to manage, and the red boxes are the stuff that the service provider manages. And so when it's on site, when you build the service or the server, let's say, you build the server, you build the data processor, data center, whatever it is, the computer, any of those things. When you do it, you literally go from the bottom up. You set up the network, the storage, the server itself. You got to virtualize the machine and install the OS on it. Then there's the middleware, which is everything in between the OS and the actual applications. Then the runtime, the data, all of that you have to manage. Networking, storage, servers, and virtualization are all offered by the cloud provider, by the service provider. And then all you got to worry about is the OS, middleware, runtime, data, and applications. And this is for infrastructure as a service. Then when you go platform as a service, they literally offer all of these things, and all you got to worry about is the data and the applications. And then finally, software as a service, they provide everything. They literally provide everything. You don't have to worry about installing any of this stuff. You just use them at this point. And it becomes less and less for you to manage and worry about the further along you go with all of these things, okay? So the deployment models would be public cloud, private cloud, or hybrid cloud. And public cloud is resources provided by a cloud provider that are shared among multiple customers. So you could have multiple companies be a customer. So organization A will use resources from the same hardware and offer services to any other organization. For example, Microsoft Azure and Amazon Web Services are examples of public clouds. However, they also offer virtual private clouds services. So you could have two organizations using the same server, right? That could be a public cloud. Private cloud, customers don't share the underlying resources, hardware or software, and resources are dedicated to one single customer. So organization A will get their own virtual machine hosted on a system specifically dedicated for that particular customer. And then you have hybrid, which is the combination of public and private. So organization A might want to use some private cloud resources for themselves to host confidential data, but then they also want public cloud just so, for testing applications and software so that the production system doesn't crash during the testing. And then you have the important terminologies, virtualization, we talked about in the last video. In this specific pathway, in this module actually, computing, so defined as processing power customers require to run applications and data for processing and carry out different tasks. In cloud computing, customers can get computing power from a combination of virtual machines hosted in their environment. Then you have storage, which is pretty self-explanatory. So you don't need to maintain physical hard drives when you're using the cloud. Instead, the data is stored in logical pools of physical storage on the cloud provider's premises. And then you can scale up or scale down based on what you would need. And then networking, as cloud computing is a system of computers and processes that are interconnected. You have a network. So you maintain a high-speed network and you need to have that connection, and that's very, very important. So the cloud provider is responsible for providing network connectivity to meet customer needs without disruption. So in infrastructure as a service, what will be the deployed by the vendor, the hardware or the software? And so if we're going to infrastructure, that refers to the physical stuff, which is the hardware. And then what is the type of cloud dedicated to a single customer? And that is a private cloud. So we got all the stuff that we would need for architectural concepts. And now let's jump into cloud security concepts. All right, now that we understand what a cloud is and what cloud infrastructure and software and platforms are, the key concept that we need to understand is that we need to protect stuff that is inside of the cloud. And the infrastructure, for example, the physical hardware of stuff, of a server, The physical hardware is protected by Amazon if we're using AWS. So Amazon has security guards, they have warehouses, they have security cameras, and all those things. They protect that physical infrastructure. So you don't have to worry about protecting the physical stuff. What you need to worry about is protecting the digital stuff. And that in this case is considered to be data. And it's an asset that can be anything, any piece of information that a customer or organization has, and it can be categorized in different levels. So you have confidential data, and it's considered the most critical data. And it could be something like credit card information or customer information, and it can damage the organization's reputation and include personal identifiable information. So anything, if something happens to this data, it damages the business in many, many ways. Then you have internal data, and it's information that if it was exposed, it causes moderate risk or harm to the company, but not as much as if their confidential data was released. And then you have public data that it's literally available to the public. You can go to their website and anybody can get access to it. So there's literally no consequence if it's leaked because it was meant to be leaked. It was meant for people to view it publicly. So when you look at this series of information, these categories of information, you can consider their life cycle, the data life cycle. And in our world, in the modern world, companies use and store large amounts of data, including critical and sensitive data of their customers. And if that stuff is on the cloud, it needs to be managed through the life cycle to ensure secure usage in every phase. So these are the phases. You create the data, you store the data, you use the data, share the data if necessary, archive the data, or destroy the data. And it all leads, so in banking, for example, there's a 3-year life cycle or a 5-year life cycle for certain pieces of information. And then once that information has gone past that 5-year life cycle, it has to be destroyed. So it's created, it's stored, it's used whenever necessary, it's shared whenever necessary. Once it's done with this specific portion, it becomes archived for future reference. And then after a certain number of years, they just destroy it because it takes up space. And sometimes you don't need it anymore. It becomes outdated. So if it's outdated and it's not needed anymore, it has to get destroyed so it opens up space, but also it alleviates the liability. It removes liability from the company that is storing it so that they don't have to worry about, it leaking or it getting accessed by people that shouldn't access it. So when you look at this life cycle, then you need to consider the security aspects in that life cycle. So each phase requires protection, and the life cycle stages, security considerations and requirements for all of those stages are individual, but there's a lot of overlap in all of these things. So when you create or update data, then you need to make sure that you implement SSL or TLS, which is essentially security algorithms or encryptions, we can call them. So secure communication through SSL and TLS so that it's difficult for the attacker to listen while the data is being created or transferred between the customer and the cloud provider. And then you have the encryption that the data should be encrypted so that if it's exposed for whatever reason or if somebody can listen in, they can't just read the data, right? They would have to go through certain decryption methods to be able to read that data. And then finally, you have the secure connection between you and the cloud provider so that the data transfer and the change of data is minimized and there is no worry about somebody listening in on your communication with the cloud service provider while you are creating or updating your data sets. And then when the data is being stored, so based on its form, if it's structured data or unstructured data, and stored in a container generally known as some kind of a database, there needs to be encryption of that data and backups happening regularly. Backups can also be referred to as redundancies. So if you have encryption of data, which is fairly easy to understand, you encrypt it so that it can't just be accessed willy-nilly, and people would need to go through certain decryption processes to be able to get access to that. But then the backup is just another one of those things that if the data is lost for whatever reason, the server crashes, the warehouse burns down, there's an earthquake, there's a hurricane, anything, whatever happens, there needs to be backups. So redundancies and backups usually refer to, if there's a location in California of a server that you have your data on, You also want that same data to be stored in a location in Texas. And then you also want that data to be stored in a location in New York or something. So you have three different backups of that data. And if something hits the West Coast and hits California or hits Texas, at least you have your other locations that have backups of your data. And then regular scheduled backups, so that if there's any major updates to your data and the systems and all those things, the scheduled backups ensures that if anything does hit the fan, you don't have to go back and recreate a lot of the stuff that happened since your last backup. So it's all very, very important. And then you have the usage of the data. So if the data is encrypted, it has to be decrypted so that it can be used by some kind of an application. So the secure connection comes back into play. Notice how we had secure connection on the creation and updating of data. Now we're looking at secure connection so that we can have a good path of communication before the data is transferred or used, and the confidentiality and the integrity of the data is ensured. And then you have a secure platform that is using it. So an authentication mechanism needs to be used so that it can be protected from attacks and vulnerabilities. Restricting permission so that there's only a handful of people who can access it. And then once the owners of the data create and set strict permissions to be able to read, modify, delete the data based on their rule sets, and then anybody who's unauthorized shouldn't be able to do any of that stuff. They shouldn't be able to read it if they're not supposed to. They shouldn't be able to write to it or delete it if they're not supposed to. And then you have secure virtualization. The concept of virtualization in cloud computing, which stores among users, which resources among users are shared. So this is one of the concepts in virtualization. So the cloud provider needs to make sure that the customer's data is not visible to another customer's data, right? So if I want to virtualize my data, somebody else shouldn't be able to virtualize my data. It should only be available to me, which goes to restricting permissions, which goes to the security of the platform and the security of the connection, right? Then you have the sharing phase. So there needs to be a jurisdiction. There's a lot of regulation that is attached to this. Certain states have different regulatory requirements. Certain countries have different regulatory requirements. There's standard regulatory requirements that go all across the board with everybody, but each state, for example, in New York, has like strict rules for insurance companies, for example, or banking. And so their rules are much more strict than another state that doesn't get as much business, therefore doesn't get as much attackers, right? So if there's a lot of busyness that's going on inside of that state, it means it's going to be susceptible to more attackers. So they have to have more regulatory environments and restrictions to make sure that their jurisdiction is better protected. Then you have DLP, data loss prevention, which goes across the board with a lot of stuff as well. So data loss prevention helps to detect and prevent data breaches or unwanted destruction of sensitive data. That's really, really important. It just happens sometimes that randomly, if you don't have "are you sure you want to delete this" notification that pops up when somebody accidentally clicks delete, then all it takes is for somebody to misclick something, or their mouse pad is dirty, and so when they're trying to scroll to an area, it just jumps from this area to this area, and all of a sudden they clicked delete accidentally, and there was no notification to verify if they wanted to delete it, and now the data is deleted, right? That's crazy. Or if it gets deleted, it actually gets fully deleted, and it doesn't go into a trash bin, for example, or a recycle bin, and then it's actually completely deleted and it can't be recovered. All of that stuff is, it sounds silly, but it's very, very possible that it could happen. Then you have archiving. So encrypting the data so that once it's archived, it can't be decrypted easily. Physical security of the archive, right? Because typically archives mean that they're now going into some kind of a storage device, and so the storage server needs to be physically secured and prevented from unauthorized access through biometrics or cameras or guards or electric fences, something, whatever, like any kind of physical security. The location, which is the physical location where the data, the drives themselves are stored. And there's stuff like natural disasters and climate, too much humidity and mold can destroy certain things. So all of these things need to be considered when you're considering where you want to store your devices, or store your storage. There you go. Backup procedures. So how will the data be recovered if something does happen? And how often do you need to have full or incremental backups to make sure that all of your stuff is current in the archives? And then you have the destroying of the data once there is no use for it and it can't be misused by anybody, or you don't need it for whatever reason, then you just get rid of it. Crypto shredding is a process which encrypted data is useless, and by destroying cryptographic keys, so without the keys, data cannot be decrypted. So if you just delete the cryptography that is securing those data sets, then you're technically destroying access to it. So this is all stuff that you would go through just to make sure that you're securing the various aspects of the cloud life cycle. And then you have security issues that happen in the cloud and the solutions for those things. So data confidentiality is a security issue. When data is inside the cloud, the privacy of that is at risk, and so the users have no physical access to that data. Once it's been stored into the cloud, they don't know what they have to worry about when it comes down to the confidentiality of the data. And so the cloud service provider can examine the data of the users without any kind of a detection, and that falls under confidentiality of data. The virtualization issue allows for the resources to be shared among users. So we need a mechanism to ensure that the isolation and secure communication between virtual machines is happening. And users aren't isolated in a multi-tenant environment, so one user can examine the data of another user. That's what that means. That's what virtualization means. So one user should be able to get access to their own data without another tenant being able to access their data while they're virtualizing the data. Then you have insecure interfaces and APIs. So cloud services are managed by customers with the help of software or APIs. You get access to the API of, Endpoint Manager in Azure or something, or Intune or something like that. Those are endpoints that you're using. So vulnerable software APIs can be risky, and data and customer confidentiality and integrity are at risk. So this is actually one of the big deals. Like if you're storing your data and you're running your business through a service provider that inherently is insecure, that means that the hacker, all they have to do is hack that service provider and they get access to your information and everybody else's information that's using that service provider, right? So they don't need to hack you, they just need to hack the service provider that is storing your information, and now they have access to everything. Then you have insiders who are malicious. So malicious insiders can cause data breach of other clients, taking advantage of shared technology vulnerabilities. These insiders can leak the data of other users, or exploit security weaknesses, thus causing security threats to the other customers on the cloud. So how many times, I literally just got one from AT&T earlier today, that they were like, or maybe it was yesterday, but it was sometime recently, where there was like, oh, there's been a breach in AT&T's information. It was posted on LinkedIn that AT&T's data, something across like 76 million users, their data was breached and leaked. And it's like, could that have a malicious insider, or could it have been an insecure interface and API of AT&T, right? Isn't that crazy? And then you have the account or service hijacking. So you can hijack a service or an account, and they include phishing, vulnerability exploitation, password reuse among users, dictionary attacks, brute force attacks. All those things can fall under hijacking. And then you have access control mechanisms, which is in a cloud computing environment. Users and cloud servers are not in the same domain. Enforcing efficient and reliable access to information is critical when the data is outsourced to the cloud. An unauthorized person can gain access to the data due to a lack of access control rights. And that all falls under access control mechanisms and whether or not they're secure or weak. So what is the first phase in the cloud data lifecycle? It would be to either create or update the data. And so then what we got to do in this case is we got to use this view site button at the top right here to go ahead and answer this last question, which reveals a flag for us. So this is what we got here. And it says, do you know about the sequence of steps in the cloud data lifecycle? And your task is to select the correct option for the highlighted steps. So we have 100 seconds. So it includes the newly created data and data that is being freshly imported from other data sources. This is called the creation. And then you have data is processed based on its form, unstructured or structured. That would be use. It's not use, so let's see. Stored. So that's what it is. Then we have encrypted data is decrypted in this stage for optimal usage. So that's probably use. Data is shared within or outside of the cloud infrastructure, and that is shared. Long-term storage of data and applications, that's probably store. Oh no, archive, excuse me. That's archive. And then undesired data is shredded or removed, and that is destroyed. And there we go. We got our flag right there. Copy that. And then we're going to paste that here. And there we go. So we got cloud security concepts done. So let's now jump into cloud security risks concerning deployment models. All right, each cloud security model or cloud deployment model, excuse me, each cloud deployment model has associated risks. So when you have private cloud, there's personal threats, natural disasters, external attacks, malware attacks. When you have public cloud, there's the vendor lock-in, conflict of interest, escalation of privileges, and then community cloud, vulnerabilities in policy administration. These are literally just a few of the vulnerabilities or associated risks that go along with these types of clouds, right? So you can go deeper into this because it all technically falls under the OWASP top 10 sets of rules. And if you haven't heard of this, we've done videos of this, and I literally look into this all the time. The last deployment of the OWASP top 10 was 2021. And so OWASP stands for my God, I can't believe I've forgot it already. It's the Open Web Application Security. Hold on, what does OWASP stand for? The Open Web Application Security Project. Yeah, I was right. Okay, good. I was right. So it stands for the Open Web Application. So Web Application Security. So when you use a cloud service provider, you're using a web application technically. And when you're using a web application, there are security risks associated with that. And the last update of the OWASP top 10 list was this, right? So, and you can see from here each one's, if they went down in criticality or severity or if they went up. So 2017 was the update, and then 2021 was another update. And in 2017, for example, injection attacks were a really big deal. So they were the number one, and then they dropped down to number 3. And then sensitive data exposure ended up going to number 1, or no, excuse me, number 2, which goes under cryptographic failures. So sensitive data exposed means that it wasn't properly encrypted. And then you had broken access control went from number 5 to number 1, which means that the access control. So 94% of applications were tested for some form of broken access control, and common weakness enumerations, there are 34 of them mapped to broken access control, had more occurrences as application. And then you can just go Google that to see what that means. But I mean, there's a lot of actually like really good videos that's around this as well. But you could just literally do some Googling about these different these attack vectors or these different vulnerabilities to understand what web applications go through and how you need to secure your web applications. And a lot of companies will say that we operate based on the OWASP top 10, and you need to understand what that is. You need to know how to get access to this list. You need to know how to protect for it. And then there's a lot of open source stuff that's available, and then there's a lot of stuff that you can get from YouTube or just paid content, stuff like that. But if you just go through this stuff right here, how to prevent, examples of attack scenarios, references that are for the, if you just go through what's available on the OWASP website, you would be good. You would have a better understanding than most people of how to understand what the list is, how to measure a company's posture against the OWASP top 10, and then from there how to remediate and protect against it. So that is what that is. So You have the cloud security risk concerning the different deployment models. And so you have the private cloud. So personnel threats, it includes unintentional and intentional threats from the personnel. So they don't have control over the providers, data center and administrators, and any insider can cause damage to the customer's data, either intentionally or unintentionally. So that's the personnel of the service provider. Then you have natural disasters, which is very basic to understand. Then you have external attacks, so such as unauthorized access, man-in-the-middle attacks, and distributed denial of service attacks that can compromise the user's data. So if we're the user and we're talking about the cloud service provider, somebody attacking the cloud service provider affects us, right? Then you have the public cloud. So the vendor lock-in means that the customer becomes a dependent service provider in the public cloud. It becomes nearly impossible for the customer to move the data out of the cloud infrastructure, the cloud infrastructure end of at the end of their contract term. Thereby, the customer becomes the hostage of the provider, right? So if you're locked in with your vendor, and for whatever reason you're not current on your billing or something happened with your vendor, and now they have all your data locked in and you can't get access to your data because of the fact that there was some kind of issue with you and your vendor, and now the customer, being us, become a hostage of the cloud service provider. Isn't that crazy? Then you have threat of new entrants. So the cloud provider may provide services to your competitor in the public cloud. And an escalation of privilege authorized. In the public cloud, users may try to acquire unauthorized permissions. A user who gains illicit administrative access can be able to gain control of devices that process other customers' data. And then you have the community cloud, which is vulnerability. Any node may have vulnerabilities which can cause intrusions on the other nodes. And in a community cloud, configuration management and baselines are almost impossible, meaning very difficult to enforce and very difficult to manage and notice. And then you have policy and administration to enforce decisions and procedures in the community cloud. It's very difficult, posing a severe challenge and a threat. So community clouds are essentially computing and storage infrastructures that are shared between a community or the members of an organization. So that's what that is. And public cloud we already discussed, and private cloud we already discussed. But a community cloud is kind of like a hybrid cloud, but not really. It's like shared between a community. And if you have a membership on the Hive project, for example, we discussed that in several videos ago. But a Hive infrastructure, the Hive project allows you to have a community around a certain case in cybersecurity that your company may be dealing with. And so that has its vulnerabilities, and enforcing policy and administration changes on those vulnerabilities can become challenging. So that's really basically the difference between these different clouds and then the security risks that go to those clouds. So the answers, the questions here is, in which cloud model does the customer become the hostage of the cloud provider? And we talked about that over here, right here. So it's the public cloud, which allows it for the vendor lock-in situation. So it would be the public cloud model. And is it challenging to enforce specific decisions and procedures in the community cloud? And we already discussed that, and that is yay or yeah. So there we go. We got that down. Now let's go to security through access management, which if we went back and looked at the OWASP top 10, the first thing was broken access control. That was the first issue that was available in the OWASP top 10. That's the most recent one, broken access control right here. So security through access management. Let's talk about that. We discussed IAM, Identity and Access Management, in the first module of this pathway, of the Security Engineer pathway. So you can go and find that, the Identity and Access Management video. You can just literally search through the channel contents for Identity and Access Management, and you'll be able to find that video. But access management and IAM is becoming more and more important. I actually had an interview earlier on this week with a very large company. I'm not going to disclose the name of the company, but it's a global company, very, very large company. And one of the big things that they were concerned with was my ability to understand access management, identity and access management. So you're probably going to run across that as well. So what it means is that the right people should do the right job within the right set of permissions. That's what identity and access management stands for, or what it means, right? So you create identities. So the cloud infrastructure creates digital identities that can relate to a person, a user, API, or service, and the entity is a set of properties that can be recorded, right? Then you have authentication factors. So each identity is allocated with a specific set of characteristics unique to that particular identity and helps to distinguish it from other identities. So if those things are matched, if the identity and the authentication factor are matched, then the essence of that user is confirmed. And so the authentication factors could be their username and password, or their username and PIN, the biometric fingerprint or a scan of their face, or a certificate that is attached to their session, the Face ID I already mentioned. So there's a lot of different factors that you can have to authenticate yourself. So you have an identity, the identity needs to be authenticated, and then you have roles, right? So each identity has a specific role which defines the domain, under which that particular identity functions. So that role gets access to certain services inside of a certain domain, and they are allowed to do those things according to that role. And every time that that person wants to go and access those services, they have to provide their identity, authenticate themselves, and then they go and get access to the services assigned to their role. So a bank teller has a different role and different permissions than the bank manager, and they should get access to different things according to their roles. And it's basic to understand. It's very, very basic to understand. It's just really freaking important to understand, and really important to have security around these concepts. So who can access what? That's identity access management. Really, really basic. And I love this. This is very, very simple. Who can access what? That's it. Who falls under user, the identity can access management. What are they going to access? So in Amazon, access management is implemented through identity and access management. IAM is considered the heart of access management services to configure and perform fine-grained control and access policies to AWS resources. It's a web service that enables Amazon users to grant access to various services and resources to different users. Features of IAM. So give rights and permissions of resources in your Amazon account to other people without sharing passwords. Grant role-based access to users based on their access rights. Enable multi-factor authentication. Enable and manage permissions and access policies across Amazon accounts and resources. And this is not just limited to Amazon, by the way. It goes across the board with everybody, every service provider. It's just that Amazon is the example in this case. You have some important terminologies in this case. Resources are the object within a particular service. They include the users, the roles, groups, and policies. All of these things fall under resources. These are all resources. Identities represent certain users permitted and authorized to perform specific roles and actions. Entities are the subset of resources which are used for authentication purposes. It includes the users and their roles. They're all considered entities. And principals are a person or application requesting to use Amazon resources after signing in. So these are IAM terminology specific to Amazon. Okay, Azure can have different labels for these things, but they typically represent the same description. So their label might be different, but it represents the same description. Using the cloud environment. So we're going to be using examples from AWS through this room. Although the room can be completed with the provided text and image content, the practical exercises require an AWS account. Having an AWS account is optional for this room, but if you're interested, you can visit this URL to understand how to create and activate a new AWS account. So let's go over here, and for the hell of it, I might actually just create one just for the purpose of this thing. We'll see if they said that we can probably answer the questions through just the text, but I would recommend that you just go, because it's free. You can set up the AWS account for free so that you can go around and click around and see what's going on. but it's important to, at the very least, to read through the text and watch this video, etc., etc. But I think it's useful to go create an AWS account just so you can understand what's going on. So create an IAM user account with administrative privileges. In the account, IAM users with administrative privileges will have complete access to AWS resources. Moreover, it can grant permissions to other users. So you log in by going to console.aws.com, navigating IAM, go to the users and navigation pane, click add users, which is IAM, users, add users, enter the new username, assign the access to the AWS Management Console, which is what you want them to have access to, so that they can actually be an admin, so to speak. And then you go to next, and then you go to permissions, and then you add them to a group, and then you got to create a group if you don't already have one, which in this case, if you're creating a new account, you won't already have one, so you got to create a group. And then you're going to do administrator access for the group itself, which is a permission policy. So it's a group policy that's already been established. So once you have the group name, you do administrator access as a policy name, which gives them full access to everything. And then you create the group and then review to go through the settings. And if everything's all good, you do create user, and your user has been created. And then you can save the details for that user as such. So are Face ID and biometric types of authentication factors? Yes, they are. And then we've completed the practical exercise. I guess I should do this. So I'm going to do it just for the hell of it, just so we can kind of follow along with this whole thing. Okay, I did not create an account with AWS because it requires that you put a credit card as your initial sign up. And I honestly, out of pure laziness, did not do it because I didn't feel like going to the other room and grabbing my wallet and taking my credit card out of it. So I didn't finish setting it up, but I think we should be able to just learn from what we got over here with the information on the screen. We should be able to kind of pull through, but just to give you more experience with it, I think you should go create one. I do have an Amazon AWS account. It's under my actual name, and I didn't want to log into that account, and I was trying to create a new one under Hank Hackerson, and that's where I kind of ran across the thing. So I do have an AWS account, and I know how to navigate it, and I just do recommend that you go ahead and do it for yourself. Do as I say, don't do as I do in this particular case, because I'm super lazy right now, so I apologize for that. Okay, so let's jump into security through policies. Policies are a set of guidelines and controls which attach to identities, which are roles, and make permissions for those identities and those roles. The cloud infrastructure evaluates the permissions defined in the policy to determine whether the request should be allowed or denied whenever an identity requests any service. In a typical environment, these basically following types of policies. So you have an identity-based policy based on a specific person and the permissions that they're allowed to have. You have a resource-based policy based on what they're trying to access. And then you have a session-based policy. So their identity could be also the role of the person. The resource could be based on the data or the services that they're trying to access. And then a session is temporary policies for specific resources for a particular amount of time. So security policies through AWS, they are by the AWS IAM, and you just go to policies. So you click on IAM, click on open policies, and then it'll just bring you to the wizard for creating a policy if you don't already have one. You click on create policy, and then you have either the visual editor or a JSON version. And if you don't know JSON, then you use the visual editor to do so. And then you just choose a service that you want to attach your policy to. So this is what it looks like, right? So you choose a service, and then from RDS, in this particular case is the service, you want to specify kind of action that they could do. So you're going to do all RDS services, and then the resources that are attached to that, and all resources that are attached to that. and then the conditions. So multi-factor authentication required, or a source IP that should be able to use it. And then you click next, and then you assign a name to your policy. And from there, you can assign even a description to the policy, the summary that goes attached to it, any kind of key or a value that would be attached to it, and then you can just create your policy. And once it's been created, it'll show up on your policy list, like here, you see right here. And then from there, you can just go create another one, for example. So this GIF is basically going to repeat itself, but very simple to do. So what we did was used RDS and denied all the permissions, and we can attach the policy with an identity so the user cannot access the RDS service. The primary idea is to have granular level of access control through policies to restrict or enable access to a specific resource. In a cloud environment, can we create a policy to enable database access for a user at a specific time of the day? And that is called yes, and that is a session-based control, as we talked at the top right here. So session-based policies. We have completed the practical exercise. So I'm going to say yes, but I did not do that because I was too lazy to create my AWS account for this session. But yeah, I mean, you kind of see what it's like, right? So don't do as I do as I say in this case. All right, moving on to security through network management. Cloud computing is different from the on-premises model of computing, wherein including physical firewalls and protect on-premises deployments, all those things are a little bit different since you're using a cloud service provider, and then the physical protection is done through the actual service provider themselves. So network security of cloud infrastructure is maintained through a layered approach, and we have the 3 layers here. The network security through security groups, which is the most fundamental aspect of network security, and it basically is the allowed rules or allow rules that allow specific traffic to get access to resources. Contrary to traditional firewalls, security groups do not have deny rules. The absence of any allow rule against a particular traffic means that it's denied. So you basically explicitly allow something, and if you don't want it to be allowed, you just don't check the allow button, right? So we can say security groups operate on the principle of deny all unless allowed explicitly. Then you have layer 2, which is network security through network access control lists. And the concept of NACL is related to protecting the virtual private cloud, and they are used to create rules to protect specific instances of the private cloud. And network access control lists are different from security groups in the fact that NACLs contain deny rules as well, and we can make a rule to block a particular IP address from accessing the virtual private cloud. Then you have the layer 3, which is the vendor-specific security solutions. So service providers are also well aware of the inherent weaknesses and cyber attacks that can target their infrastructure, so they have deployed their specific security solutions. And these vary from vendor to vendor, meaning AWS has different rules, and for example, DNS firewall and network firewall, both. So network security in AWS falls under several components, which is the security group, the network access control list, the DNS firewall, and the network firewall. So what we can do in this particular case is when you go to AWS account and you navigate to the VPC in the services menu, which is on the left-hand side, or you can just search for VPC in the search bar at the top. It'll open up the virtual private cloud for you, and then you get your set of options for that. And so under security, you have network access control list. So NACL, network access control list. And when you click on it, you do create a network access control list. And then you go through the wizard, basically, right? So you give it a name. Then you can attach any virtual private cloud to be used for that access control list. You have any tags that you want to attach to it. And then you have your inbound rules, your outbound rules, and any associations with the subnets. And if you don't know what subnets are, I do recommend you go look into that. I think we have a video on subnets. I don't know. I don't think it's like a deep dive on subnets, but It's fairly easy to understand. It kind of seems complicated, but I would recommend you just kind of understand it. Network Chuck has a really good video on subnetting, so you should go check that out if you haven't already. Then you select new ACL and click on the inbound rules, and you create a new rule. So under inbound rules, you can edit inbound rules, and then when you edit the inbound rules, you can essentially start editing it. Very, very simple. So rule number one, on port 22, which is secure shell, which is a TCP port, and you say that the source address uh, from any port essentially, or any IP essentially, is denied, right? That's the specific rule. So it denies all the traffic at port 22. And you can allow list or block list specific IPs for connecting to port 22 when you add more rules, right? So you can just add another rule on the same port, and then you say the source IP address is the specific IP address that you have, and then you just do allow for that. So it denies everything with the exception of that one IP that has an allow permission. The question is it a good practice to operate security groups on the principle of deny all unless allowed explicitly? And I'm going to say yay for that. And that is it for this particular section. So now what we can do is go into security through storage management. Storage security in a cloud environment ensures that the data must remain safe while at rest, meaning it's not being used, and in transit during the various phases of the data lifecycle. You could create geographical boundaries, which is the regions that can access it, and then set policies permitting data access or denying data access. You can set role-based authorization, which is the identities and their roles that can access a particular data set per their specific rights and privileges. And then you have the encryption of the data. So all cloud service providers allow data encryption at rest. You should do that. you should definitely do that. With this approach, server-side encryption is applied to the data, meaning while it's inside the server and it's at rest and it's not being used, it's encrypted. Some important things to understand here is connection strings with the database containing a hostname, username, and password must be used using secure methods, right? So encryption, basically. Access security policies, data encryption standards, and physical security measures by the cloud service provider. All these things are very, very important to understand when you're talking about storing data. And then in AWS specifically, we can look at a lot of different types of repositories to store the data. You have the relational database services, simple storage services, Redis, and a lot of other things. And data security is ensured by applying various policies to database instances per the data sensitivity, right? So how sensitive the data is, if it's confidential, or if it's hybrid, or if it's just meant to be internal, all of those things. So if you go to AWS and navigate to S3, which is basically, it can be searched for inside of the search menu at the top. You just type in S3 or simple storage service. That's what S3 stands for. You will find the S3 service, and then from there, you click on create a bucket and enter the basic information such as the bucket name, the region, which means the physical region that you want it to be stored at. And the bucket name must be globally unique, meaning that no other people can't have access to that bucket name. So you just need to create a bucket name specifically for you. And it could just be the name of your business dash the name of the bucket, meaning what kind of data is being stored in it, dash the location that you want it to be at. And that usually is unique enough. And then you can just create your bucket. And so default encryption, encryption type would be the managed keys, which is the basic default encryption, or it could be a key management service by them. And then the bucket key is enabled. You just want to make sure that you enable your bucket key so that it encrypts your data bucket. And then enable server-side encryption and select encryption key type. For the demo, we've used the S3 magic keys. And then you create the bucket and you have your first S3 bucket. The encryption of data at rest is unnecessary. If we carry out encryption at transit, that is not the case. You need to encrypt your data. And so just so you know, when you do this, an S3 bucket has cost associated with it. And I want to say that network access control lists don't, but I do know for a fact that when you create a database, an S3 bucket, there is a cost associated with it. So if you are actually doing this in real time and you're going to create these things for yourself, make sure if you're not going to use them and if you're just doing it for practice, to delete all of these things at the end of this video so that you don't get charged for them, especially if you're literally just doing it just for the hell of the exercise and just for going through the motions and going through the process. So finally, let us jump into cloud security and just some additional concepts around cloud security. There's a concept in data recovery that is called disaster recovery and backups that are associated with disaster recovery. And cloud disaster recovery is a terminology that became really famous as clouds became really famous and really popular. So it's a combination of approaches, tools, and techniques that ensures to back up the data just in case there's a disaster so that you can recover that data or any of the resources or applications that were used through your virtualized machines and your instances. So to ensure regular continuity of business operations is why we do this. And the essential concepts are as follows. So you have cold DR, cold disaster recovery, which is the most straightforward approach and inexpensive, but it has the largest recovery time objective, meaning to get back to business operations, it takes the longest time if you just use cold data recovery. And it basically stores data and saves images, and these are disk images or snapshots of the machines that you have, so that basically whatever software you had that was installed, you would just virtualize that software, reinitialize that operating system with all of the softwares and everything already installed on it. That's what a disk image is. And all snapshots must be recovered to resume business operation in a disaster situation, right? So if a computer crashes and it has a bunch of things installed on it and a bunch of data in there, you need to be able to retrieve that virtual machine. You need to be able to retrieve that computer with all of the data as well as all the software and everything that was installed on it. Then you have the warm disaster recovery, and it's the near real-time synchronization of the actual data and applications with disaster sites. So a copy of all the data and services is being maintained at the data disaster recovery setup, hosted on a cloud environment, and it's just being kept as a backup to resume business operations in case there's something going on. And when a disaster occurs, the disaster recovery site is configured to resume operations, and in this case, it's the time required for configuring the disaster recovery site to become operational. And then you have hot disaster recovery, which is practically zero recovery time objective, and it's the most expensive. So in this approach, the disaster recovery sites works in parallel and shares the workload through load balancers. In case of disaster, all work is shifted to so a company that has a lot of need for their operations and their services to be up all the time would do something like this. But if you're just running a personal website, it's probably not necessary for you to do this, and you can just do cold disaster recovery. Then you have security through monitoring and logging. So there's real-time logging, which all service providers monitor and log all identities and resources. Then you have monitoring and logging of API calls, which has the instances have provision for recording API calls made to the infrastructure. So a GET request or a POST request, all those things. And the logs include the source IP address of the user or the service and the time and their geolocation, etc., etc. And then credential reports, which is another essential thing that that cloud service providers monitor, and user account logs. Common log factors include the user account, the last used date, and the password last changed, password last used, all that stuff that have to do with the credentials, the actual users themselves. Then you have monitoring and logging into AWS specifically, so IAM, identity and access management, basic logging features related to access management, logs and credential reports of user accounts. Then you have CloudTrail, which logs all the API calls made to the AWS resources, CloudWatch, which monitors the entire cloud infrastructure and informs about application status performance changes, ensuring better resource utilization, and guard duty, which ensures continuous monitoring of any malicious activity and unauthorized behavior. So if we wanted to do this practically, we would need to go back to IAM and go into the console, navigate to IAM. In the navigation pane, you then go into access reports, and under that you have the credential report, and then you can download your credential report on the next page, and it gives you an Excel sheet. And then from there you get the root user, their specific username and the networks that they're assigned to, the user creation time, the user update time, a lot of that stuff. The report is going to be downloaded in CSV format, and it use password last used, password last changed, user creation time, stuff like that. Updates and patching. There's something called patch management in AWS, and you can have automated and scheduled patch management. Patch management in AWS is managed by Systems Manager, and it has the following concepts. It ensures automatic and scheduled updating of cloud resources and to update operating systems and their applications. Provides scanning option to scan complete infrastructure regarding the missing patches. And if you wanted to access that, you would go to the System Manager in AWS, and from there you would open Patch Manager, which is going to be in your left-hand side menu, and that's going to be under Node Management. So you go to System Manager, on the left side menu you go into Node Management, and when you do the drop down, you get to go to Patch Manager, and then when you open up Patch Manager, it brings you to the Create Patch Policy wizard, and then you can have a patch without a schedule or scheduled patching. So you create the name for it. You can do scan or just scan and install. And recommended defaults, it can scan your nodes daily at this time, or you can create your own scan schedule, and then that's basically it. And then it'll just scan your services for any updates that might be necessary, and then you could either just get an update for what needs to be installed, or you can just do scan and install, and then they'll do the updates for you automatically. So question here is it a good practice to keep disaster recovery backups for a server in the same vicinity or data center? Is it to keep disaster? I would say nay. Yeah, that is the answer. So there it is. We are now officially complete with our room here. So that was it for our cloud security introduction. And as a quick little conclusion, this is what we went through: security through access management, through policies, networking, and storage management, and things like logging, disaster recovery and backup, and updates, and all those things. So this is a really, really big topic. So cloud security in general, cloud computing in general is a really big topic, and companies hire people specifically for cloud management, and then it even falls into different subcategories of that. So they'll have different departments under their cloud management. They'll have different, and that includes cloud security, right? So all of these things are really, really important for you to understand, especially if you want to go into security engineering and cybersecurity, stuff like that. If you got any value from this video, or if you want to be updated on the new content that comes out through this channel, I do recommend that you like, subscribe, and turn on the notification bell so that you get notified the next time that we drop something. And that includes everything that comes through the security engineer pathway, which we are currently on right now. So the next thing that we're going to be doing is the cloud monitoring, or not, excuse me, the auditing and monitoring room, which is going to be the very last piece of the network and system security module. And then we're going to go into software security. That, look at that, it is going to be OWASP top 10 as the very, very first room that we're going to do there. So I would very much love for you to actually join our community and come come through the comment section and check all these things out, and I think you'll get a lot of value from it. So make sure you like, subscribe, and turn on the notification bell. And yeah, that's pretty much it for that one. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. Later.